Good morning, everyone. I'm sure I'm not looking my best this morning, but I wanted to make sure that we moved forward with our class. I've been gone now. Today is day 4. I really apologize. My son still has a fever, and hopefully it's breaking today. And maybe I will even be back tomorrow. We'll see. But in the meantime, I wanted us to get moving on what we've been learning about naming ionic compounds. I want you all to have this worksheet 5.5, the one that's listed right here. Today we're going to learn how to name ionic compounds with polyatomic ions. In your sheets, what that meant was that you had a, let's see, when we go to ionic compounds, remember this. When we go to ionic compounds, it would be the part that says ternary, 3 types of atoms. And if you notice on your worksheet, you have 3 types of atoms, or maybe even more, but minimally 3 types of atoms. So this is how you name it. Let's look at this handout here and read what it says. Ternary, 3 types of atoms or more. For example, CaNO3 2. Identify the polyatomic ion. Okay, so that you're going to need to do with your periodic table. So everybody should have a periodic table out as well. Here I have our periodic table. Hopefully you can see that. You notice on the top, I don't know if you can see my cursor. It's sort of a hand right now. Let's see if I can change that. Let's see if I right click on that here. You have this section on the top here called polyatomic ions. These are groups of nonmetals that bond together covalently but have a charge. So they form ionic compounds, and they always stay together in an ionic compound. So for example, in the example that's on your form right here, let's go back to that for a second. The example that's on your form, CaNO3 2, the polyatomic ion is that NO3. Okay, and you'll learn whenever you have a compound that has 3 or more atoms to name, that's ionic, by the way, that has a metal. Okay, anytime you have a metal and more than 3 or more than 2 atoms or 3 atoms, you're going to look at your periodic table. Let's go back there, and you're going to identify that polyatomic ion. Here is this one right here, by the way, the one that we were just looking at, NO3. It's called nitrate. Let's see if I can zoom in here. It's called nitrate, and it's NO3 with a 1- charge, or -1 charge. It exists as a group as if it were one element or one ion only. The NO3 stays together, it doesn't break apart. So here we have NO3-. So going back to our foldable, it says the first thing to do is to identify the polyatomic ion. We just did. That polyatomic ion, in other words, the part that's not the metal, usually, I mean there's 1 or 2 exceptions to that, but mostly the part that's not the metal, NO3, occurs together as a group. It is called nitrate. Okay, so it says to name the metal. Ca is calcium, that's the metal. And nonmetal, you know what? Here's a mistake, actually. I see on our foldable, you're going to have to cross this out. We do not change the ending for a polyatomic ion. That's what happens when I cut and paste and put this together, okay? So we name the metal calcium, and then we name the nonmetal, which in this case is the polyatomic ion. Maybe I should rewrite that, name metal and polyatomic ion. There is an exception where you're going to have a positive polyatomic ion. If you look on your charts, there's only 1 or 2 of them. Let's go back to our periodic table. Are there any here that have a positive charge? Let me see here. Here, right here. Ammonium is the exception, NH4+. That's why I put that there, is that sometimes the cation, the part that's the metal, is actually replaced by a polyatomic ion. So this is NH4+. It's called ammonium. It's not ammonia. Ammonia is NH3. Ammonium is NH4+. So I name the metal and polyatomic ion, or polyatomic ion and nonmetal. So name calcium, and we know this is nitrate, and it says do not change the ending of the polyatomic ion. So the naming of this is calcium nitrate. Okay, so that's just like what you learned. Well, some of you had been asking me, how about those things that end in 8? Well, that's what this is that ends in 8. It has to have a polyatomic ion to end in 8, calcium nitrate. If I did this same thing, if I had a polyatomic ion but I had a multivalent metal, remember my single valent metals are the alkali metals, the alkaline earth metals, and group 3, right? And the exceptions, silver, cadmium, and zinc. Those are my single valent. So anything else, like in this case, Au is gold, is going to be called a multivalent metal. So let's see what the instructions here. Au2CO3. Identify the polyatomic ion. Okay, so we're going to go back to our periodic table. What was it again? We're looking for CO3. CO3. Oh, here it is. Here's a CO2. That's not it. CO3. Okay. Carbonate. So we identified that metal, that polyatomic ion is carbonate. Do not change the ending of the polyatomic ion. Name the metal with the charge in Roman numerals in parentheses and the non-metal. And of course, again, another mistake. You don't change the ending of your polyatomic ion. Okay, I said that up above here. So you identify the polyatomic ion, carbonate. You keep it as carbonate. And you name the metal with the charge. Remember how to figure out the charge of the metal? I don't know if I have a stylus here to write on it, but we can look at this. Carbonate has a 2- charge. And we have 2 golds, Au2CO3, right? Au2CO3. Carbonate has a -2 charge, and we have 2 golds, totaling a +2 charge. So we know that each gold cation must be a +1 charge to add up to +2. It says here, since the total charge of the total charge of the 1 carbonate ion totals -2, we know that the total charge of the gold ions must total +2. Since there are 2 gold atoms, each one must have a charge of +1. So we name it gold 1 carbonate. Okay? So that's how you name multivalent ternary compounds. So let's go to our worksheet. Here are polyatomic ions, and here are these are ionic compounds with polyatomic ions. When we get to the second part, they want you to write the formula. Let me see if I can find my stylus. Just one sec. So we're asked here to find the formula for the compound barium sulfate. We know from the periodic table, barium has a charge of +2. There we go. I was a little delayed here. Barium has a charge of +2. It's an alkaline earth metal. And sulfate, because it ends in 8, we know it's a polyatomic ion. We're going to go back to our list of polyatomic ions. Sulfate is there. Sulfate, SO3 2-. So we know that the sulfate is SO4 2-. SO4 2-. And since Ba2+ and SO4 2- cancel each other out, they make a charge-neutral compound. We know that the ionic formula for the compound is BaSO4. We're going to try the next example, ammonium sulfide. Ammonium sulfide, remember ammonium is the one exception. It's the one polyatomic ion that's a cation on this list. Ammonium is NH4+. It's got a +1 charge. So we write that down, NH4+. And then we have sulfide. The fact that it ends in "ide" gives me a hint that this is a single ion. This is not a polyatomic ion. I'm looking at hydroxide underneath, and I know hydroxide is actually a polyatomic ion as a cyanide, but most polyatomic ions don't end in "ide." So sulfite is probably, well, I know for sure, is sulfur, the anion of sulfur. So going back to the periodic table, we see sulfur's over here. Sulfur requires 2 electrons to have an electron configuration like argon, so it forms the ion S2-. So now we don't have a charge neutral compound. We've got NH4 plus 1 and S2-. What do we need to do to make a charge neutral compound? We need to add an entirely new, an additional NH4 plus. And again, these polyatomic ions stay together. They act like one single unit. So now the 2 NH4 pluses add up to plus 2. The sulfate is minus 2. So the formula is NH4 but there are 2 of them. So if I write the 2 here, there's something a little awkward. It doesn't work. It doesn't apply to the whole thing. So in order to show that I have 2 ammonium ions, I need to put parentheses around the polyatomic ion and put the 2 just outside of it. In fact, let me clean that up a little bit. Notice, by the way, with barium sulfate, I didn't have to write any parentheses around the sulfate because there was only 1 of them. So the parentheses are not required unless I have more than 1. And then we know that there's 1 sulfide ion, so we just write that. That's ammonium sulfide. So that's it. Good luck. I know you guys can do this. This worksheet is due tomorrow. I hope I'll be back tomorrow. My son is feeling better this morning already. I think his fever broke. I hope. This other slide of this is review of all types of ionic compounds. So do the naming as well. The naming won't be homework for tomorrow, but worksheet 5.5 is homework for tomorrow. Good luck, and I hope to see you tomorrow.